and Zia Midavi. Are you speaking together or separately?
Not together, but
okay.
one
So
after the
Naveen
other.
is professor here in the Sustainability and also the Institute for Policy School. He's also an associate of our sustainable systems. Naveen's research program aims to understand how humans use and modify the Earth's land surface for agriculture and its implications to the global environment. Zia Midavi is a postdoctoral fellow in IRES for global issues and the Center for Sustainable Systems. He's worked on large-scale farmland expansion in sub-Saharan Africa. He's worked in nonprofit settings on developing environmentally conscious decision support tools for land managers, and he's worked with small-scale farmers on the interactive effects of agricultural intensification and climate change. He's also one of the people that's helping us vision a long-term monitoring strategy along with finally, last but not least, we have Ms. Carolina Machado, who is visiting professor of the Management Peace and Animal Welfare Program. He is a co-professor at the Federal University of Santa Cruz, where he leads a research group on animal agroecology and animal welfare, focusing on the behavior and welfare of dairy grazing and pasture management. We'll present on how the balance carbon balances rather than emissions alone should be considered when evaluating. I'd like to welcome all of you, and we'll start with Mike, and then we'll just go straight down our road. We are filming the panel discussion, and that's partially so that capital research group has to show and see this the panel and discuss it. So we have a little microphone, but we're going to just this is for the video. So you just put that in your pocket. Just clip this to your there. All right.
Thanks.
Make sure it's turned on.
Yep.
Can I see that?
And then this was on just a minute ago. Yeah. It's just one.
While they're getting set up, I will just put a plug for our next Global Food Dialogue series. We were meeting on March 7th for NSA Emancipatory Politics and Food Sovereignty. Just to note that seminar will be postponed to the fall. So even if you were planning on attending that, we'll send out a notice next week just to remind people that it's postponed. But we do have Michael Winter on March 28th, also talking about sustainable intensification, and that will happen in the two as well issues. So please do check our Global Food Dialogue webpage for other seminars.
All right. Okay. Thanks everyone for coming, and thank you for the invitation.
No, that mic is just for the film.
Okay, then I can.
There's a lot of fans in this room.
Okay, so I'll have to speak up, and then I can click here. Okay, great. Can everyone hear me? Okay. Good morning, everyone. Thanks for coming, and I'm happy to give you this presentation here today at this great panel discussion. I took a look quickly at the Grazed and Confused report last week, and there's a list of what this report does not focus on, and one of the points is hydrology, land use, and water catchments, water footprints, and water pollution. So I thought I'd give you a very quick rundown what that looks like. So first of all, maybe you've thought about this, maybe some of you are working on this. Does anyone know how much water is required for 1 kilogram of beef? Anyone? Maybe this is not something you've thought of. The answer actually is sort of in the Grazed and Confused. It sort of depends, really. The first global assessment was given by the Water Footprint Network at roughly 15,400 liters per kilogram. So that's liters of fresh water per kilogram of beef. But other assessments came along, and more recently in Australia, where we get one value of 5,800 liters per kilogram or up to 55,000 liters per kilogram. So really, it really depends on what the production system is, what method is used. So these are different methods here. And also there are some geographic realities that have to be taken into account for these types of assessments. So I'm not sure how familiar you are with the water footprint, but I would say that most people actually think of a water footprint as this, as fresh water volume and pollution for a product and service. That's only partially true, because today it's actually a little bit more than that. There's an ISO standard for water footprint, principal requirements and guidelines, which provides this framework, including a water footprint impact assessment step, which I won't have time to go into. But what's important here is that the water footprint actually includes both water quantity and water quality in the assessment. So what's water quantity here? We call that fresh water consumptive use. So that's use of fresh water that doesn't return to the watershed because of either evaporation, product integration, or direct release into the sea, or sometimes some interbasin transfer. So those are some of the challenges in trying to figure out how to include that in the beef production system, because it's more than just drinking water, right? So what are the consumptive uses of the beef production system? That's sort of an important question. And can we simply sum up all these different consumptive uses? And also, how can we compare different products or these different species, or the Australian beef versus the Canadian beef, and so on? We also talk about freshwater degradative use, so this is now the quality side. That's discharge of water into the same watershed, but at different water quality. And again, we have some challenges here. What are the degradative uses of the beef production system? There's hundreds of chemicals, of course, being released from the manure side to pesticide or fertilizer, and how do we account for those? And what are the environmental consequences? So I'm just going to give you a very brief overview, focusing on this one step, which is the amount of liters per kilogram of product. And I won't have time to go into the rest, but this is an important step in the water footprint assessment. And my area of interest is Southern Amazonia for various reasons. It's the agricultural powerhouse of Brazil, with 8% of the world's soybean being produced in this one state of Mato Grosso, which is roughly the size of British Columbia. And there's 30 million heads of cattle grazing on roughly 30 million hectares of pasture. And all of this agriculture here is rain-fed. So one chapter of my thesis actually looks at modeling this in detail, looking at this one species called Nelore, which is 90% of the species in the state of Mato Grosso in southern Amazonia. And I look at what we call cradle-to-farm gate. So basically, I'm not looking at the slaughterhouse or transportation to the slaughterhouse, making the beef product into the packaging and so on. I just look at the animal basically ready for slaughter at roughly 48 to 51 months of development. And what's important here is that the entire development of the animal is on grazing, roughly. There's some difference at the finishing stage, where some of the animals are in feedlots for roughly 6 to 8 months, but it really depends on the area. So we have some models, and I looked at this in detail for Southern Amazonia, looking at this one model that was provided for Australia. And of course, you have to sort of think about what the consumptive uses of the beef production system is. So there's, of course, drinking water, which is an inflow, but there's also an outflow of the water. But we also have to consider the environment that the animal is living in. So the animal's grazing, the animal's also drinking water from perhaps a small farm dam, and those are also consumptive uses. So there's pasture evapotranspiration, which would be the fresh water consumptive use of pasture. So that's the evaporation of water from the soil or transpiration from the plant during photosynthesis. That has to be considered in some way. And then, of course, there's the farm dam evaporation, which is also a consumptive use. So does that get attributed to the beef production system or not? Those are important questions that the community is still trying to understand better. So I calculated this and also looked at remote sensing to try and detect where these small farm impoundments were in the state of Mato Grosso, to try and allocate the evaporation to the beef production system. And this is a very broad result of basically 1 kilogram of live weight of the animal in southern Amazonia requires roughly 350 liters of fresh water. And if you look at this more carefully, most of that fresh water consumption comes from the evaporation of the small farm dams, followed by drinking water. So this is a drinking water value that's converted into a consumptive use. and then the water in feed, which would be actually physical water that's in the feed or mixed with the feed. It's not the freshwater consumptive use for the evapotranspiration of the pasture. That's a separate production system. And here you can see two different systems, a low productivity pasture and a very high productivity pasture, where I did some modeling to figure out what the consumptive use of water for those two systems would be. And we get roughly 20,000 to 50,000 liters per kilogram of live weight. So you can see that in this case, the freshwater consumption of the beef production system could increase considerably if you add the pasture evapotranspiration. And the question is, should we actually add it? We had 350 in the previous slide, plus 20,000. Should we actually add these two values? And my answer is no, because they're very different systems. As I said, on the top we have the pasture evapotranspiration, which is entirely rain-fed, so the environmental consequences of that are different than, let's say, drinking water of the animal and other potential inputs that would go into the animal production. So my recommendation in this chapter of my thesis is looking at production system efficiencies, perhaps looking at pasture productivity to look at differences in water use for pasture, and also looking at perhaps the reservoir evaporation to reduce the water use into that production system. But if we looked at the actual environmental consequences, at the environmental impacts, and that would be the step I didn't mention today, which would be the water footprint impact assessment, then we can combine the environmental consequences into something a little bit more comprehensive, including the water quality side, which would look at the nitrogen and the phosphorus consequences, the CO2 equivalents that my colleagues are going to talk a little bit more about, and then we would actually be able to look at decision making on the volumetric side, so the production efficiency, and also the environmental impacts, looking at the consequences of that water consumption and then water degradation. So if you're interested in this, the FAO is actually leading the Livestock Environmental Assessment and Performance Partnership Group, which has just released this draft for public review. I mean, the deadline's already passed, but it's basically some guidelines as to calculate the freshwater degradative use in beef production systems. Actually, it's more than beef, it's actually livestock. Keep your eye out for water consumption. This will be coming out in a few months. So if you're interested, I really recommend that you visit the website. There's also some groups on biodiversity and so on. And if you're interested, you can actually join this group and participate. So those are my 10 minutes. Thank you very much.
Okay, so my starting point is in the same region that Mike just talked about, in the Amazon. And I'm using this as a starting point because Kako mentioned or found one of our papers and which was talking about deforestation in the Amazon. So I'm going to use this as a launching point. So for everyone knows the environmental problem of deforestation in the Amazon, and then you can ask, what's the cost of deforestation? And so there was a lot of confusion and debate when the soy boom was starting in the Amazon. People said, soy is causing deforestation, but then a whole bunch of soy farmers said, no, we are not causing deforestation. Most of our soy is going into abandoned pastures, so we are not causing deforestation. It's actually ranching that's causing deforestation. Greenpeace actually did their own study. They partnered with some people. They got whole bunch of Landsat imagery in the Amazon, and they analyzed the imagery, and they also concluded that in fact most of the deforestation is caused by ranching. And this is a summary from MongoBay, which does a lot of writing on Amazon deforestation. It says that cattle ranching contributes to about 65 to 70% of deforestation. Small-scale agriculture is about a quarter. Large-scale agriculture is only 5 to 10%. So the kind of soy, agriculture. This is over the 2000 to 2005 period. But then this is the paper that Kako was talking about. One of my master's students and I did some work, and this is just one illustration of what's going on. We talked about this idea of displacement deforestation. And this is the idea that, yeah, indeed, it's pastures that are actually causing deforestation at the frontier. But if you look further south in Mato Grosso, where Mike was doing his work, if you look at what's happening to soybeans, this just shows trajectories over the 2000 to 2006 period. Soy is moving further north. Pasture is also moving further north. So what's the story is that soy is replacing pasture down in the frontier. The land value is going up for soy. The ranchers are selling out their land. They are moving into the frontier. They're causing deforestation. So you can say, yeah, in the proximate, in the Amazon, maybe it's ranchers that are causing deforestation, but they have been shifted from Mato Grosso in the southern regions where soy is pushing in. So soy is indirectly causing deforestation. So then you can say, okay, it's soy. It's not grazing. You can't blame the grazing animals for deforestation. Then you ask, what's happening to that soy? Why are we growing soy there? Is it for tofu, or is it for something else, right? So where is the soy going? Well, a huge amount is going into the EU, but a quarter of the soy or so is also going to China, and it's to feed pigs, mostly to feed pigs, so it also feeds chicken. So it comes back again. The soy that's causing deforestation comes back to our diets again. It's going to feed people's meat consumption, right? So the bottom line message for my piece is to say it's not really the animals I worry about so much. It's the resources that we use to produce the animal feed. That's really the major problem. And a simple way to say that is, this is just a cartoon that, let's say you're eating different kinds of burgers, a veggie burger or a chicken burger or a hamburger in the bottom. And let's say you're getting the same amount of energy from all three sources. Well, you have to feed these animals, and it takes a lot more to feed the cow than to feed the chicken than if you were to get it directly from the grain. It's just simple loss of energy as you eat further up the food chain. Vaclav Smil, who's a very prolific author from the University of Manitoba, he's done a lot of the work in trying to calculate these conversion efficiencies that a lot of people use. These are crude global numbers, and as Mike talked about, if you look at water requirements versus land requirements, you get different answers on what's better to eat. So if you care about water, maybe you should eat eggs. If you care about land, and if you care about calories, you should eat milk or eggs. If you care about protein, maybe it's better to eat chicken and so on. But the bottom line from that graph again is like, don't eat pork and beef, right? Like, you can get confused, but if you care about any of those things. Here's another chart illustrating the problem. So just focus on the bottom three. This is rice, wheat, and maize, the three major crops we grow on this planet. And the total calories produced is the full bar. The green is the amount of calories that are delivered to human calories. So it's either calories delivered directly to humans or it comes in the form of meat. Okay, so the red calories are basically lost from the system. Okay. You can see rice and wheat are mainly food crops, and most of the produced calories are delivered to humans. But with maize, the biggest crop we grow on this planet, only a quarter of the calories actually come back to humans. So you take the Midwestern US, some of the best climate, the best soils in the planet, we grow corn. Most of that corn doesn't come back in the form of human calories, other than high fructose corn syrup, cornstarch. So this study estimated that if you shifted crop use to direct human consumption, it would free up something like 70% more calories. Right? It's another illustration, just a global map showing the same thing. The green colors show places where we have more food calories. The red colors show fewer food calories. So again, U.S., Europe, Eastern China, most of those places, all the crops produced don't feed humans. So that's just a summary. The big problem is that only of all the crops that we grow, about 36% of the energy in those crops goes to feed cattle. Only about 4% comes back to feed humans again. right? And about 9% goes off to other stuff like biofuels and things like that. So Z and I have been working on a paper looking in more detail, and he's going to talk about that. Do you want me to switch? Yeah. Switch it out.
Diversity of attachment points.
I know.
Never missing any kind of attachment to the diet.
Okay, so thanks everybody for coming, and thanks for that introduction. So I consciously became a vegetarian when I was 10. So I've been thinking about livestock and about eating meat and eating animal products for about 20 years now, or more than 20 years. And I don't know if any of you seen the kind of the advertisement that went around with to advertise this event, but there was a picture of me on the front. And Millens, who's the director of IRES, said to Naveen, "Oh, Zia looks like an evangelist on the front." But I can assure you, everybody in the room, I'm not here to convert you today. What I'd like to talk about is leverage on the Sustainable Development Goals and the role that the livestock industry plays in that. And if there's one kind of key leverage point, or there's one kind of key take home, it can be illustrated by this figure. So this figure shows you the protein supply, that's in grams per capita per day, to some different countries across the world. On your left, we have high consuming countries, and on the right, you have low consuming countries. And it's split out by whether these protein supply is coming from animal products or vegetable products. And what you can see is that high consumers are consuming almost double the global population requirement of the protein that they need. And most of this is coming from animal products. There are a number of countries across the world, typically low-income countries, that don't get enough protein in their diets, and about 25% of their protein on average comes from animal products. If we're thinking about leverage points towards sustainable development in general, what we're really talking about is removing this overconsumption of animal products. We're not talking about global vegetarianism or global veganism, which doesn't make sense for these low-income countries that don't get enough protein. And that's a critical point to take into mind. So this is just a summary of many different data sets and global modeling studies. It's a synthesis kind of graph, which shows the effect or the impacts of the livestock industry, different estimates of them, for a range of social, ecological, and environmental outcomes. You can see some benefits up here in the green. There's something quite interesting that I found out. If you look at the World Census of Agriculture, 23%, 24% of the farmers that have been asked actually own a cow. So a quarter of the farmers or so in the world, cows are very important to their identity. About 30% of the farm gate income globally comes from livestock and animal products. And as you saw in the last graph, about 25% of the protein supply in low-income countries comes from the livestock industry. But then there's this suite of these negative outcomes, and Naveen's touched on some of them. About 36% of our calories are going into the feed that produces animal products. And then we have these negative health outcomes. About 3% or so of child mortality under 5 from zoonosis can be linked to the livestock industry. We have non-communicable diseases such as heart disease and so on and so forth. And about 50% of our antibiotics that are applied globally are going into the livestock system. This obviously has problems not only for environmental health, but also the evolution of antibiotic-resistant pathogens. And then in addition to these health impacts, you have all of these kind of environmental impacts, and these have been touched on a lot in the media, and you would have heard about these. So 22% of our planet's surface area is going towards kind of pasture and growing livestock to eat. It's a large contributor to greenhouse gas emissions, 10 to 15% of our water use and water pollution, and 25% of species that exist in areas where pasture is or where livestock is today have been lost due to that conversion from their natural habitat. And all of these different kind of negative impacts have typically polarized the debate. And so today, the general debate is that either, we should become vegan or vegetarian and this is a solution to sustainable development, versus what about the economics and what about smallholders? And that's kind of where we sit at the moment. If we try and map these on the Sustainable Development Goals, you come up with a picture that looks something like this. So all of the Sustainable Development Goals are each from 1 to 17 are at the top here. And this is the interaction between each one of the targets. There's 169 targets within for the Sustainable Development Goals. And each of these have been mapped in terms of how they interact. So whether they're positive, whether they're negative, or whether we expect mixed outcomes. The mixed outcomes are quite interesting, but they're quite obvious if you think about the graph I just showed you on the page before. So livestock are important for smallholder farmers. They're important for nutrition and protein supply for people that don't get enough. At the same time, we're wasting loads of calories. It's leading to obesity, and we have massive healthcare costs as well. Similarly, if you think about climate change, large contributor to climate change at a global scale, but locally, livestock offer a system of resilience for farmers. So when their crops fail, they can get energy from livestock products. And for people that live in variable environments that rely on livestock for sources of protein and so on and so forth. So it's an important resilience mechanism. So you have these kind of mixed outcomes. The kind of key take home from this is that there's really no obvious, clear way to navigate these trade-offs, right? What is interesting, though, is that there are potentially some common threads that run through it. And one of those threads is what I like to think about as vulnerable populations. And very simply, I know things are quite complex as we talked about in livestock system in general, but I like to simplify things and just to try and model it in our minds. If you think about vulnerable populations, very simply, we have basically two on the planet. We have one set, a subpopulation that is vulnerable because they don't get enough protein to eat, and they could benefit from the economics of a livestock industry, and we should help them in that. And you have another subset of the population that are typically over-consuming animal products. And I like to think of those as vulnerable because they're just as vulnerable. They're vulnerable to advertising, they are vulnerable to eating, over-consuming animal products. And this is having a negative impact on not only their health, but on the environment and the health of other people. And so I just want to end on this, and a last kind of calculation that I've done that's kind of interesting and you can take it home with you. And it relates some of these kind of ideas to your actual plate. So this is quite an interesting thing. If you took all of the protein in the world that comes from animal products, the non-fish animal protein, so we're not touching fish at all, just touch, or any other protein that comes from, that does not from fish, so we just leave fish to the side for the moment. It's a kind of controversial. And we just take all of the other kind of animal products that are out there. And each week, if you ate 3 portions of white meat, 3 portions of red meat, 3 eggs, and 5 glasses of milk, and everybody did this in the world, we would have not only more than enough protein to consume, 17 grams more than we need for population requirements, but we would be able to reduce our global protein consumption of animal products by 43%. Which means basically halving our impact on the environment. Which is quite cool, right? I mean, you can have a pretty good meal of red meat once a week, which is pork, lamb, goats, steak. Pretty good meal of white meat, and some eggs and a glass of milk every working day of the week. And still, we could basically halve our environmental impacts and massively reduce our health impacts of the livestock industry. So in terms of leverage for sustainable development, I think it's this. Thank you.
I'll just set the It'll be hardly accepted in Argentina. Just put in here, then.
Not least, Professor Machado.
Okay. Oh, great! Thank you very much. Thank you very much. I don't know if this is my computer or. This is. Yeah. And perhaps we just do have any pen drive?
Do you have a USB drive?
Yeah. I think it's my computer that is too old.
So we're going to put his presentation on a USB stick and move it over. So maybe we'll take a couple questions for these three speakers while we do that. So yes, in the back. And remember just to speak up because it's a large room.
My question is twofold. One is, so a lot of this we don't sort of talk about the other attributes, or non-quantifiable attributes of culture, age, other stuff. And I wonder, whether something that will talk about that and try to. The second is the little bit that you mentioned about advertising. So that gives me the question for whether this pattern of protein consumption across different countries is so. Has that changed over years and has that changed also in industries like advertisement and other sectors like the food industry, certain kinds of protein?
So, answering the second question first. Typically, in terms of correlates of protein consumption, the most prevailing kind of analysis or sets of analyses that have been done have been to correlate protein consumption with GDP growth. I haven't come across any analysis that's actually tried to tease the GDP growth from advertising. Typically, those things are going to be highly, highly correlated. And so without like a randomized experiment, it's going to be quite hard to actually determine causality there. Perhaps you could do some smaller scale studies within consumer communities and see whether those two things influence. But I'm not aware of a global analysis that attempts that. In terms of culture, yeah, I think that's one of the critical things that's missing. People have talked about it, and it's very important. But I don't think it's really. When people talk about consumption and lifestyle, they typically one side of the spectrum,
Just put it
and
here.
it's very polarized. And
Oh, all right.
what it
Very
comes down
smart.
to is very, very contextual. And it's just, the application of sustainable development goals depends very much on each country, each region within the country, each community within those regions, and even cities. So
Thank you.
that kind of context is critical.
All right. So thank you for that information. And back
Okay.
to Professor Machado.
All right. Thank you. Sorry for that. It means that my computer really needs to be replaced. What is a shame that we have to replace computers every 6 years or so. Should have more sustainable, lasting computers, whatever. Okay. Well, it's a great pleasure to be here and to collaborate with UBC, with Animal Welfare Program, and now with Hannah's group that she was so many times in my university, in my building, next to my office, and I only met her here. It was a great pleasure. Okay, to start, I want to present to you shortly work we just published in Frontiers last December on carbon storage from pasture and from crops, and how these would account for the dairy, for milk production. I work mostly with dairy, although also we like to work with beef cattle as well, but basically the major is dairy. First of all, I want to say that it is my opinion that the problem is not animal production, it's the type of animal production we are using nowadays. Like, you can't compare a feedlot in US that spends like 5 gallons of, the equivalent of 1 gallon of gasoline in energy, fossil energy, to produce 1 pound of meat with grazing systems around the world. So I think that when we evaluate animal production system or whatever other systems, we have to to make a point at what kind of system are we talking about, because they are really different. So that perhaps some people are not familiar with greenhouse gas emissions. So greenhouse gases is any gas that absorbs and re-emits heat in the atmosphere, warming the planet. And there are basically the most well-known are 3 that we talk about. It's carbon dioxide, which is considered with value 1 regarding warming, and then methane, that is 25 times the carbon dioxide, and nitrous oxide, which is 298 times the carbon dioxide, meaning that if you release in the atmosphere 1 kilo of nitrous oxide, it is like releasing 298 kilos of carbon dioxide, right? That's what it means. So lately, a great attention has been given to the role of enteric emissions from ruminants in global warming, especially since FAO published 2 worldwide very influential reports. The Stanfield, which is the long shadow one that you are all familiar with, and Gerber, which is the tackling the global warming, something like this. So livestock farming has been considered responsible for 14.5% of all greenhouse gas emission in the planet produced by humans, of which beef and dairy would represent 41 and 21% of emissions respectively, either from pasture-based or confinement systems. So that's a calculation from everything. Lately, the Grazed and Confused acknowledge that while grazing livestock have their place in a sustainable food system, that place is limited, more or less in the line of the last speaker. So the sequestration of carbon by pasture plays a very important role in partially mitigating the greenhouse gas effect through ruminant production systems. And carbon sequestration occurs principally as a result of the fixation of carbon by photosynthesis. And photosynthesis is something that, what is, okay. It's a very simple equation that transforms carbon dioxide plus water with the energy from the sun to organic matter, carbohydrate, and release oxygen in the atmosphere. Without these, we wouldn't have life in Earth, right? This is the base of life. Without photosynthesis, no life, no vegetable, plants, and no plants, no animals, right? Because we all eat directly or indirectly, we eat plants. We eat, in other words, sun. So if you can have a system that is rely energetically on the sun, well, that's just very economic, right? And very sustainable. So carbon dioxide from the atmosphere is stored as soil organic carbons. SOC as we call it. And this is a mixture of partially decomposed plants, animals, microorganisms, all the organic matter that is stored as a carbon in the soil. In pasture, more than 90% of the carbon stock is stored in the soil as soil organic carbon. Soil has the largest terrestrial carbon stock. That's very important. And I want to make here a very brief observation. It is carbon storage is not only in the forest, it is also on natural pastures. And natural pastures are a big share of the natural earth landscape, right? Just to give you an example, in Santa Catarina, my state, you guys are working in the north of Brazil, I work more to the south. We no longer have the forests, but we have lots of agriculture, family farming agriculture. We used to have 1.5 million hectares of natural pasture in Santa Catarina alone. Today, we have less than 400,000 hectares. What was done with these 900,000 hectares? Basically two things. Pine tree, which is a monoculture of these trees you have here. It's come from North Hemisphere, it's not natural, it's exotic. Or soybean. Those are there, right? So they are also altering the landscape and also are responsible for lots of emission because you disrupt the soil structure and you release, that's the most release of carbon is when you disrupt the soil structure. Voisin rational grazing is an agroecological pasture management system that brings together practices that increase and conserve the soil organic matter through increased biocenosis. So in this system, the area divided into small plots is occupied based on the growth dynamics of the forage and the needs of the animals. So basically, we rotate every day or every 12 hours to a fresh pasture. This system has been widely used in south of Brazil. In Santa Catarina, more than 600 projects have been implemented, mainly by small dairy farmers. So this is an example. This is in Neifresa, Jupiá, west of Santa Catarina. It's a small farm. It has like 10 hectares of pasture, no more than that, which means about 20 acres. And the cattle are in small paddocks. Here's the water. And they change every 12 hours to a fresh new paddock with fresh food. That's the idea of the system, right? Well, this was the paper I was talking about. This was a master thesis of Izumi Seo, which was a great student. Stocking carbon while producing food in agriculture is a relevant task production systems on mitigating climate change. So if we can store carbon when we produce food, that's the best scenario, I guess. Everybody would agree on that. As more carbon is stocked per unit area and more food is produced per carbon stock, the better the balance is. In this work, we compare the carbon stocks of two different systems of feeding ruminants. Grain-based from the most widely used carbon conservationist grain production system, no tillage, and pasture-based from VRG, an intensive pasture management known to incorporate many carbon conservationist practices. And here we study 5 farms. Farms are here. And here we have the average 10 hectares, the area of pasture, with about pasture estimated producing 22,000 kilos of dry matter per hectare, stocking rate 3.4 cows per hectare, and no agrochemicals, manure, some manure is added to the soil, and inorganic fertilizer, very little. Here we have the no-field tills, typically 3.3 the area. Estimated productivity of silage, kilos of dry matter per year, per hectare, 12,600. And previous land use, Atlantic forest. Well, all of these used to be Atlantic forest. So agrochemicals, yes, they use a little bit, and inorganic fertilizer a little bit more. And here is the results. The result shows that the distribution of organic carbon in the soil by different depth is much higher in pasture soil than crop soil, both in 0 to 20 centimeters or in 20 to 40 centimeters as well, and in the whole thing as well. So this result shows that with good pasture management, we can store more carbon in the soil than with crops. And also here, the main stock is from soil organic carbon. As you can see here, 115 tons are from soil organic carbon, and only 6 are from roots and green parts of the plants. Greater carbon stock in pasture soil than crop soil is usually challenged by the fact that 1 hectare of crop would produce more food than 1 hectare of pasture, right? I mean in animal production. However, this statement depends very much on pasture management. Pasture management can significantly affect carbon stock. As more efficient the management is, applying correct stocking rate and allowing regrowth, higher carbon levels are stocked, and also higher production is obtained. Using data from our field study, we estimated what would be the production of milk per hectare from VRG or from no-till fields. Further, we calculated the quantity of milk produced per carbon stored. As more carbon is stocked per unit area and more food is produced per carbon stock, the better the balance. So we took from NRC requirements and feed tables the potential for milk production in 1 hectare of no-till corn plus ryegrass, because this is 1 hectare. In Brazil, in Santa Catarina, different from Mato Grosso, that's only 6 months a year. You have rain there, we have rain the whole year, and we don't have snow, so we can produce the whole year. During the summer, basically, they produce corn or soybean, and during our winter, we use ryegrass or avena. Oat, yeah, okay. So in the VRG, we would produce 17,000 kilos of milk per hectare per year if all forage consumed was destined to lactating cows. Emission is 2.9 kilos of CO2 per kilo of milk produced. This is according to international figures, right? And no-till, we would produce 12,240 kilos of milk per hectare per year if all fed 1 hectare of corn silage intercropping with ryegrass was destined to lactating cows. Emissions 2.6 kilos of carbon per kilo of milk. Carbon stock in VRG soils were 115 megagrams of carbon, and in crop fields were 92.5. On pasture emissions per kilo of milk are 1.1 greater than in a no-tillage field, so would be more efficient in no-tillage in using grain than using pasture. This is because of the ruminal fermentation process. On pasture, carbon stock are 1.24 higher than in no-tillage fields. So this is overcome by the more stock. So if we make the balance, the on-pasture system would end up with a better balance. We estimated that on pasture it produces 0.15 kilos of milk per kilo of carbon stored. And in no-till corn silage plus ryegrass, it is produced 0.13 kilos of milk per kilo of carbon stored. In this study, VRG managed pasture stored more carbon, produced more milk, and produced more milk per kilo of stored carbon than corn silage plus ryegrass from no-tillage fields. And this was a study done here in 2002, and I took this data just to show that it is expected that on-pasture system would produce less than freestall cows. Those are cows at the third end of lactation, days in milk here when they start experiment. And you see here there is this is the first week, so they change the environment. So, but we can see here, yes, there is a difference of 2 to 5 kilos of milk per day from free stall to pasture because the feed is better in the free stall. So the prevailing assumption that animal production must grow to meet demands for high animal protein diets in affluent and increasingly in emerging economies needs questioning. This is from Grazed and Confused. And I would like to challenge this statement because I am sorry, but I am a little bit offended by this, right? Because if you see here, relative evolution of world population, meat and cereal production and undernourished. This is data from FAO. You can see if 92 everything is 100%, so the increase in world population is this blue line. The undernourished is this purple line, reduced. Cereal follows the increase in world population, and total meat production is higher, right, than the others, and is proportional somehow to the reduction of undernourished. So this has to do with the graph showed by Zia, that there is a very difference in the consumption of protein from different countries. And this is a very interesting paper that came out in Nature Sustainability this year from these authors, where the title is A Good Life for All Within Planetary Boundaries. They didn't finish the sentence. It should be a good life for all within planetary boundaries is not possible. That would be the real thing, right? So they conclude, for example, that physical needs such as nutrition, sanitation, access to electricity, and elimination of extreme poverty could likely be met for all people without transgressing planetary boundaries. However, the universal achievement of more qualitative goals, for example, high life satisfaction, would require a level of resource use that is 2 to 6 times the sustainable level, meaning we need more 3 planets to make the life of everybody in the planet in this high level. The good news is that if we see across the world all regions that increase their standard of life, they decrease their demographic increasing, right? Because that's very obvious. Like if you have a perspective of life, a career, a degree to take, you postpone or you organize your life to have few children. If your only distraction is having children, then perhaps you have lots of children, right? So that's what happened. And then I took an example from Vietnam here. They put all the countries in this graph. Here is the social threshold achieved, like as higher the better life. And here is the biophysical boundaries transgressed, as higher as more resources they use to achieve. So Vietnam is a good example because they have a more or less good social threshold achieved, and they don't use too much of resources. Netherlands, on the other side, has a very high social threshold achievement and use lots of biophysical boundaries. So let's compare animal protein consumption in those two countries. Here, Netherlands, 70 to 75 grams per capita per day, and Vietnam, 20 to 40, and increasing, right? So we compare, okay, just a second. Just to comment that the difference here is very high, and we cannot make a statement that we are going to penalize these guys here when there is this scenario, right? We need policies that for the whole planet, everybody will have to take account of that. All right. Is animal production responsible for a large portion of the greenhouse gas emissions? Well, this is a very interesting study It's a historical greenhouse gas concentration for climate modeling, published in a journal of geography. They are not concerned with animal production or whatever. They are only concerned in evaluating the greenhouse gas emission across the human history, and even before. With the arrival of Homo sapiens, the atmospheric composition changed, initially through activities such as deforestation and agriculture, and then through fossil fuel-driven industrial activities from the start of the Industrial Revolution. And then we see this is 800,000 years. Look at this. This is carbon dioxide. This is methane. This is nitrous oxide, right? And we see they are basically, they varied here across years, here and here. And here, close to our age, you have a surge. And then you put this in 2,000 years, and we see that the surge is about Industrial Revolution, right? So how many ruminant animals were living here and nothing happened? And if we put a closer look, we can see here that after Industrial Revolution, there was an increase, but a radical increase comes from the 50s. Green Revolution, intensification of agriculture, and a fossil-dependent society led to the sharp increase in greenhouse gas emission, as you can see here. So, according to British Petroleum Stat Review, emissions from combustion-related activities of fossil fuel accounts for 33 gigatons of CO2 per year. According to Fau Gerber et al. Report, emissions from animal production is 7.1. And we want to act here, but not here. So are grazing cows a better solution than banning animal production? I think yes. I think we have to change and adapt our animal production systems and make it much more rational. And you are right, we don't need, as we do in Brazil, some people eat half kilo of meat per day, right? That's in a barbecue, that's the count, half kilo per person. Perhaps once in a year. And it's very important to take advantage of this process here. For hundreds of thousands of years, the ruminant animal co-evolved with pasture and build up a symbiosis with microorganisms in the rumen. What they do, they break the celluloses. We don't break. It's useless to eat green for us. It's undigested for us, for dogs, for many animals, for all animals. It's only digested by microorganisms, right? So not to use this feature, it is not very smart, I think. And there are many areas of extensive and moderately intensive system of pasture in the earth, and this can be much improved to achieve a better production. And I want to finish showing this forest reduction. Look, this is from Brazil, right? This is 2008, 2013. Only 5 years. In 5 years, the pasture area in Brazil remained absolutely the same, didn't change. Arable land increased, forest land decreased. If we go back to 95, the number is the same. Until 95, there was an increase in pasture in Brazil. Now it's sustained and perhaps decreased. The cattle population increased a little bit. So the forest reduction is almost the same as the arable land increased, around 6 million hectares in 5 years. Well, yeah, most of this grain go to feed animals. But if we realize that United States put almost 90% of their corn production into ethanol for fuel for cars, if that would be used for animals, then perhaps this wouldn't increase. So we cannot, it's a kind of global thing. And animal production is related, especially in countries of South America and Africa and Asia, with millions of family farming. And I want you to see this nice table from these agricultures, and I want you to see the house in the back. And then we were there and we made a project, we made a conversion to a VRG system, which is economically better as well. And 2 years later, they receive us with nice table, and look at the house in the back. So this is priceless, right? And well, yeah, and we have not to forget the welfare of the cows. I wouldn't have time for that. Thank you.
I want to thank our panel for giving us lots and lots of food for thought. I think the way we'll handle the discussion is take 3 or 4 comments or questions, and then go back to the panel. We'll probably have time to do a couple rounds of that. So feel free to direct your questions to the panel generally, or if you have a question for one of the speakers in particular. And I'll just ask you folks to pass the little mic back and forth. If you're responding to questions, you can just hold it in your hand so that we can pick up the responses on the video. Okay. So maybe you can just repeat the question back to the. Okay.
I guess I'd be interested in terms of the panel's feeling, to what extent it's useful to think of these to think of livestock as a problem versus really trying to understand the specific conditions under which livestock can provide specific benefits or firstly how we might mitigate specific harms associated with any type of practice. So yeah, it's a general observation.
I was interested in how this about looking at different types of cattle, whether it's dairy, farm versus grazed dairy. I was wondering if the other fellows also speak to how we might have changes to the impact the land use change, because presumably it will
Great, so I'm going to hand it back to our panel. Maybe we could just go down in the same order if you have a response to any of the questions. I'll start with Mike.
Okay, thank you for your questions. Let's see. Maybe I'll start with particular versus the general. It's a question about how the presentations differed into being very particular. So looking at water very specifically to maybe more general, Zia's presentation on diets and so on. And I would say that definitely from my point of view in my work looking at water use, it's very much focused on production and production efficiency. So the context is how to reduce the amount of liters per kilogram of product and the environmental impact. And the problem with that is related to the last question about agricultural products, because the assessment calls for what we call a functional unit, is what is the function of the product that's being made. Is it beef? Is it wool? Is it leather? These are all byproducts of the livestock system, eggs and so on. So how do you allocate that water use in this case, in the case of water, to a multifunctional unit system? So that's sort of one of the problems, I would say, with thinking about just focusing on production efficiency. And definitely the industry is interested in pushing that forward because they see perhaps a way to be more efficient and also show that they're doing something to reduce their overall footprint, whether it's greenhouse gas emissions or water use. The more general aspect, I would say, which would relate more to what Naveen and Zia are doing, is to compare this to the planetary boundaries. So, and there's quite a bit of a jump there, going from the production efficiency mind frame, looking at functional units and products, to, okay, well, how does all of this sum up into the amount of renewable water or reaching 2 degrees or reducing our greenhouse gas emissions so we don't increase the world temperatures by 4 degrees and so on. And that, I think, is missing in this sort of conversation. Maybe I'll pass it on.
Mm-hmm. Yeah, so I'll just follow on from that. So in terms of is being general useful? I think it's very useful, and in particular, one of the I went into this project, a year and a half ago, being very biased in my view, actually being part of one side of the polarization of the debate. And digging deeper into the literature and into the data, it became very apparent on a general level that basically humans are in some way killing ourselves through what we eat. And that's happening in many countries in the world through overconsumption of the wrong types of food. And so you can get, supply side solutions or demand side solutions. Supply side solutions would be to do with efficiencies, improving efficiencies. We've heard a lot about that. But these demand side solutions are very important as well. And the reason why they're so important is because they touch on multiple aspects of human well-being. So if we're talking about well-being, we're talking about reducing obesity. We're talking about reducing, the healthcare costs that are associated with that, which exceed the value of the livestock industry, especially if you project out to 2050. So if you take this kind of holistic view, the general view, you actually come home with some of these kind of insights that actually, from a well-being perspective and a health perspective, not only an environment perspective, which is where I originally came into thinking about this from, that actually, these kind of demand side solutions are really important. And so consumption is really important.
Just wanted to clarify a few things based on Kaku's presentation. The estimate is that about 20% of the climate change problem is from agriculture and land use change. So to say the cow is not to blame is absolutely right. I mean, I think people who talk about the impact of livestock and climate change are not saying we shouldn't do anything about transportation or industry or anything else. Absolutely. About 30% of the emissions are from industry, but agriculture and land use change is one of the big sectors. And so within that sector, if we have to focus on where to make a difference, I think livestock industry does have a big impact. The second point is that there is a big difference between grazing animals on pasture using, cows can convert cellulose. Absolutely. We have a lot of grazing lands on the planet where we can't grow crops. They're too dry for us to grow crops. Animals have been there for a long time. Yes, great. But we are diverting 36% of our crops that are grown on really good land to feed animals. So you also pointed that out. There's a big difference between feedlot production and grazing land. So I think we are we are saying the same things in some ways. So I don't think there's a big difference. It's really about, I'm not talking about animals, I'm talking about crops being used for feeding animals. I think I'll leave it there.
Thank you. Well, first of all, regarding the comment of Dan, I totally agree. Yes, regardless of what we think is the best system, there are systems that are there anyways and will be there. So we have also to look at these systems and try to make the best to make them more efficient and reduce the environmental impact. I think this is the big issue. The big issue for us as humankind is, are we going to have a planet in 100 years? And this will affect all of us, regardless of being Canadian, Brazilian, European, rich or poor. So if we don't act now, and historically humans have acted to correct things and to solve problems. So I'm very optimistic about it. Otherwise I wouldn't be not even studying that. I'm thinking of that. How realistic is to feed the world with pasture? Well, we have 3.5 billion of hectares of pasture in the world, and we have 1.8 billion, I would say, cow equivalent in the world, considering all ruminants, considering cattle, water buffalo, goats, sheep. They account for the equivalent of 1.8 billion cows. This is 2 hectares for 1 cow. This is absolutely possible. There is plenty of pasture for these cows. So yes, we can have all our production system on pasture based on pasture. It doesn't mean that the cows would only eat pasture, but based on that, for all ruminant animals in the planet, considering what we have today as permanent pasture. And also we are now investigating with some good results using pasture for the crops. So we take the pasture as it is and we make a direct seeding on pasture without using herbicide, without revolving anything. And yes, we get some results. Of course, we don't get the same production if we would use herbicide, put lots of fertilizers and things like this. But still, in the same area where the pasture is, you are cropping during the summer, that there is plenty of pasture, you are cropping grains. And that's a very good thing as well. Difficult to convince farmers. Well, yes. Actually, farmers came from pasture to confinement. Was this their idea? Did they wake up one day and say, oh, I want to confine my cows? No, it wasn't. It was the whole economy. The whole economical groups interested in increasing production, in selling products for the cow to produce more, in designing whatever things that started this, and we are still in that. If you look for how many papers you have in international literature on agroecological production of milk, and how many papers you have on conventional production of milk. It is overwhelming. So we are starting, and I think that this will come as the need appears, right? And to finish, I want to say that in Brazil, Goiás and São Paulo replaced great part of their pasture where they had milk production to sugarcane to put in our cars, right? So this is also something that has to be approached. Okay, I think that any production system, the main thing we have to see is efficiency in all aspects, right? How much you spend in resource and how much it gives you as a result for the human kind. I'll show you this to Hannah.
I don't know how many of those questions, is everyone happy we kind of touched on some of their questions?
So in a second, we have 10 minutes left, and we will take another series of questions, and if they're specific to the speakers, they can just go ahead and answer them.
You'll focus on
Probably my question. Looking at the whole life cycle.
Yeah, so I don't personally, I didn't personally spend too much time. Like I said, I went all the way to the cow leaving the farm, but there are definitely a lot of studies looking at the entire life cycle of a product. So that stage that I described would be considered the resource stage going into the commercialization, transport, packaging, and waste generation. And so there definitely is a lot on that for a lot of products. The most interesting I found is not necessarily related to beef, but Coca-Cola did what they call a life cycle assessment on a can of Coke, looking at recycling, the effects of recycling. And it seems that in the entire life cycle of the product, it's really the refrigeration part that has the biggest impact. So the decision there would be to convert all fridges to energy efficient fridges, and that would offset by far any recycling that the consumer would do. So this type these types of studies are definitely exist and for beef products and fish and so on. It becomes very complicated when you start to try and find the data to feed these types of models. But in the era of big data and so on, things are coming clearer, and the resolution is becoming every time more helpful for this type of analysis.
I mean, there are a ton of life cycle studies, and one of the more widely known is one that was done in the U.S. And for the U.S. system, they found that around 80% of the total, they were looking at just greenhouse gas emissions, that 80% of the impact came from the production side. It's only the remaining 20% that along the rest of the life cycle. And then again, if you look at the transportation side, a lot of the emissions comes from what people call the last mile problem, people driving to grocery stores to get there.
Yeah, we did the same with dairy in Brazil, and it's the same. It's alike. Most of our impacts, not only energy, not only carbon, but also eutrophisation, acidification of soils, and all other consequences, are measured in the farm.
But even in Brazil, where the majority of the food for the animal protein, at least on the cattle side, is on pasture-raised systems, and you are trending towards more intensification. U.S. and Brazilian public, what they think, and they're very much, they may not be able to buy the more expensive grown product, but they do favor a more extensive type of system. In North America, we're looking at less, at least on the dairy side, less than 20% of cows that ever get seed laid grass. When we ask society is not necessarily saying we shouldn't have cows, but we want to see cows on pasture. None of your actually equations, calculations, and all that brought that into this. And then maybe because we don't know how to mathematically correct for that. But do you ever think about this?
Yes, we think about those things.
Yeah, we definitely think about them. So the question, if I get it right, was that there are consumer preferences for different types of products in the marketplace, and do we account for those in our analyses, the different consumer preferences? So typically we do on aggregate because the data we have shows demand, right? So that shows consumer preferences.
That's assuming the consumer's always knowledgeable. Like,
Okay.
do they know
Yeah.
that the milk that they're buying in the grocery store comes from cows and everything else?
So I think that there's a number and there's a plethora of different certification schemes and labeling schemes that have come about over the last 20 years and the last 10 years in particular. And there's a push by some supermarkets to really get labeling done. Other ones have done, I know Tesco in the UK, I think about 10 years ago did a big study to look at whether their consumers would want greenhouse or carbon emissions, greenhouse gas emissions carbon equivalents on the kind of labelled on the product. And they found no kind of interest from their consumers to have that on their products.
The UK, the ASO now is grass-fed, almost of 100 days grass-fed, the price point higher than on that.
Yeah. So I think on a mass scale it's changing. Yeah. So like that was 10 years ago. Now I think the public is changing. But those kind of schemes and those labeling schemes are kind of fraught with difficulty, right? So I think consumers are probably confused at the moment, and there's no clear way of really getting to them the information of what's in their product. Even if you look at basic carbon calculators, for example, which are now being implemented by the Field to Market initiative in the States, working with large grain growers, grain producers, grain suppliers, and so on, to get carbon equivalents on their products, as well as biodiversity impacts and so on and so forth. If you look at those models don't have any uncertainty on them. So, like, even if we had the data, so even if you got the data and we applied the current models, that are being used for carbon footprinting, and then gave them to the consumer doesn't really know what they're getting. It's almost like going to a shop and buying a loaf of bread and not knowing whether you're going to get one slice or 10. These things have been going back to the carbon credit question as well. Typically, the calculations that are being used are models that are spreadsheet models that are built from maybe 100, 150 experiments that are very spatially biased, temporarily limited. And so the same thing goes for the carbon market. People are saying they're going to sell this carbon on a carbon market, and then we really don't know the uncertainty bounds of whether they did actually fix that much carbon. And so this is a source of this uncertainty, and yeah, certainly we need more validation in place to.
One of the most remarkable trends in the US over the last decades has been a shift from beef consumption towards chicken, poultry, and that's apparently driven by health concerns, which Zia briefly touched upon. So one of the promising trends is that as people realize that they are over-consuming red meat, and that has health consequences, and they are changing their practices. The other thing I wanted to say is, like Zia, I agree that the certification schemes can be extremely confusing. Eggs are a good example. I realize that BC labels their eggs more, but then there's like free range and free run and organic, and even I get confused about what to buy when I'm in the grocery store. So you can imagine a normal consumer is completely confused. And they also label caged eggs.
Well, I want to start talking about the quality of milk and meat from different systems. We have done there are a number of works on that, and we have done also in Brazil, comparing systems that are on pasture organic to conventional. And the quality of the fat of the milk and of the meat is very different. The meat I eat in Canada, beef meat, is very different than meat I eat in Brazil. Right, Hannah? Right, Dan? Nina? Right? So it is different because the diet is different. It's obvious, we know that. So it is also a matter of public health to have a system where the ruminant eat as much fiber as it is possible. Regarding energy efficiency, there is a very old paper that I like very much from Steinhardt and Steinhardt, 1974, just after the crisis of oil in 73 in the United States. This paper, at that time, if we read this paper today, we look, wow, here's the solution. Everything is there to make agriculture more efficient, energy-wise. And finally, regarding Nina's question and the debate here, I think that one thing that affects very much all this debate is that we live in a urban society. Many people I teach in Brazil, where 19%, 18% of the population live in the rural areas, and more than 90% of the students of animal science or agronomy course in the 3rd semester never touched a cow. Never in their lives. My daughter, when I was taking my PhD, she was 6 years old, a chicken for me. The chicken had 4 legs, right? So we live in a urban society, and I ask basic questions to my students. How many teats a goat has? Don't know. And the mare, I don't know. And they are animal science students because they never saw a goat. Even if they saw from far distance, never touched it, right? So the urban society, and then I just finished with this. Long time ago, my father had a farm with dairy production. And then a cousin of mine went to the farm, and he was a boy, like 7, 8 years old, whatever, or less. And my father very proudly offered him the milk from the cow. And he tasted and said, yes, it's good, but I prefer the true milk, the one we buy in the supermarket. So that's actually the perception, right? And I think we have also to work on that side, to dialogue with society, with people, to make them understand the problems of the agriculture. And in this debate, the one that I most care is the worst situation is the farmer, especially the dairy farmer. No holiday, no Sunday, no vacation, no nothing, and always owing money to the bank or to somebody else.
Great. So on that note, we're at our official time now. I want to really thank our distinguished panel for their knowledge and interesting investigations they've done into this very controversial and complex topic. So we'll give our panelists a hand. Kaka will be here until at least the end of the term, so feel free to ask him additional questions. Many of these themes about intensification, extensification of agriculture will come up at our next dialogue on March 28th with Dr. Michael Winter, who's visiting here from Exeter University. Really appreciate the last comment that you made, Kako, about the importance of talking to urban people about the reality of farming and how actually these social values that urban people and really the majority of the world's consumers are placing on agriculture and on those land managers that do provide all of the food that we eat. So thank you again.